We need to calculate the area of this triangle, and we know with triangles the area is always half times the base times the height. We know the base, we need to find the height. And remember, this is the perpendicular height, so it's at 90 degrees to the base. And that gives us this right angle triangle here that we can use our standard trig functions on. So we've got our angle of 40 degrees. The height we're trying to find is opposite to that, and 8 centimeters here is the hypotenuse. So we want to use the sine function. We know that the opposite, use h for the height, is equal to the sine of our angle times the hypotenuse. And I'm not going to round this yet. I'm going to keep the full value in my calculator. So we know the height. To find out the area, we just need to do half times the base, which is 10, times this value. And the question asks us to round this to two significant figures. This example is really similar. Pause the video, have a go. And you've hopefully worked through exactly the same steps as on the example to get the answer here of 9 centimeters squared. Same idea here. I want you to work out the area of the triangle, but it will be in terms of A and B and angle C. Pause the video, have a go. I know it's a bit confusing here that we're using h for height, when with our trig function we're also using h for the hypotenuse, but hopefully with lowercase and capital, that's clear enough. So this is the opposite. So we want to find the height. We know we're going to do that again using our sine function. So we've got the sine of our angle C multiplied by the hypotenuse. And we can tidy this up by writing it as A sine C. So using our variables, we've got half times base, which is B, times A sine C. And if I just tidy up and rearrange that a little bit, let's do it alphabetically. And what we've got here is a really useful formula for finding out the area of a triangle if we know two sides and the angle between them. And it must be the angle between two sides that we know. Have a go using this formula with the triangle here. Pause the video to try that. And because we've got the length of two sides with the angle between them, we can just plug these values into the formula and it makes it a bit more straightforward. So the area is equal to half multiplied by one of the sides, multiplied by the other, multiplied by the sine of the angle. We want the answer here to two significant figures. And so knowing and using this formula just takes a bit of a step out of the previous examples we did. Have a try with this task. There's a copy in Show My Homework. Answers are there for you to check. It does go through in increasing steps, so it's really worth starting at the beginning and working through. Each one slightly different is going to be testing your knowledge in a bit of a different way. Hopefully you did well on the first task and you've made sense of the answers for those. With this second task, you've got a choice. You can either go straight into the task now, and then if you need a bit of support, you can look at the examples on the next couple of slides, or you could watch the examples first and then try the task. This question is really similar to questions 1 and 3 on task 2. We need to work out the area, and what we've got two sides, but we don't know the angle between them. To find the area of this triangle, using the rule we've got here, and that is the most straightforward way, we need to find this angle, the angle between the two sides that we know. The way we're going to do that is to first of all find this angle here, because we can do that using the sine rule. Because we've got an angle and a side which are opposite here, we've got a side and the angle we're trying to find here. Hopefully you can remember this okay from previous work you've done. When we're trying to find an angle, we want that to be the numerator. So we've got sine of x divided by the side opposite it, is equal to sine of 44 degrees divided by the sine opposite it. We're going to rearrange that. Remember, this is the sine of the angle. To find the angle itself, we need to find the inverse sine of this. Remember not to round it at this point. We can now use the two angles we know to find out this angle here. And our final step is to use this to calculate the area of the triangle. And to one decimal place, this comes to 44.9 centimetres squared. Now, it is really important with these questions that you keep your work organised. There's lots and lots of different places where it's easy to make a slip. Also remember, when you are doing sine on the calculator, remember it will open the brackets for you. Make sure you close them and don't round your answers too early. Just wait till this very last step before you round. Now again, in this question, to work out the area, it's going to take a few steps to get there. We know three sides. Remember, if we're trying to work out the area, we need to know two sides and the angle between them. So to do this, we could do it with any of the angles here. We would work them out all in the same way, and that's using our cosine rule. It's the cosine rule because we know three sides and we're after the angle. It's a trickier formula to remember than the sine rule. Pause the video quickly, see if you can write it down from memory. It'd be fantastic if you can. Remember, we can write it in different ways. I've written it in this form just because cosine C here matches with what we've got up in our area formula here. And you may have spotted I changed the A to the word area just to try and avoid confusion when we're looking at different parts of this question. It can be any of the angles in here. Let's go for this one at the top. So in this instance, with this form it's written, this is our angle C, this is our opposite side C. It's just important we remember that it's that pair we're interested in. So the cosine of our angle here is equal to the other side squared and added together. Take away our opposite side squared, all divided by 2 times those other two sides. And the calculator gives 7/11 for this. So remember, this is cosine of the angle C, but we can use this because this is what we've got here in our area formula. So the first step we've done is to find cosine of C. We can now use this to calculate the area, which is just half times, and we must be careful with the sides, so it's the ones either side of our angle. And this works it out very neatly. It's just 35 centimetres squared, so we can ignore this 3 significant figures bit here. Again, keep your work really organised as you go. There's a lot happening, but if you follow it through logically, hopefully you will be fine with this with a bit more practice. We need to bring in some different skills to help us solve this one, which is similar to questions 4 and 6 on task 2. So to find the shaded area, we need to find the area of the sector and then subtract from this the area of the triangle. So our fraction of our circle is the angle of the sector divided by 360, and then the area is just pi r squared. So pi, and the radius we can see from here is 5.2. We then need to work out the area of the triangle. And this is straightforward with the information we've got. Again, we don't want to round too early. And the final step is to find the shaded area. And the question here doesn't state what degree it wants it rounded to, but seeing as the radius here, the length of the sides is to 1 decimal place, that seems like a sensible amount. So 21.1 centimetres squared to 1 decimal place. This last one's a really tricky one. So we've got the parallelogram ABCD, and we can see that it's made of 2 congruent identical triangles which have the same area. So if we can find the area of one of them, we need to just double it to find the area of the parallelogram. We've got the length of 2 of the sides here. So to use our formula for the area of the triangle, we need to find this angle in between them. And we're going to do this in a couple of steps like we did before. We have an opposite pair of angle and side here. So we can use this and this side as our other pair and use the sine rule to find angle D. It's a lot nicer to remember than the cosine rule. And remember, if it's an angle we're trying to find out, then we'll put the angle as the numerator here. Just makes it easier to work through. And once we've found sine of the angle, we use our inverse sine function to find the angle itself. Now we know this, we can use it to find the angle here at C. And now we know this angle here at C, we know the length of the sides at either side. We can now calculate the area of the triangle. And then finally, we know our parallelogram is made up of 2 triangles with the same area. We just double this. And you might have spotted before, we could have done that in 1 step rather than these 2 separate steps. Either way should get you to this answer. And we want it to 3 significant figures. So that's 43.9.